Good afternoon.
So in the last class, we have seen multi-access protocols. Multi-access protocols we have seen, all right? So in that, the very first one is the one persistent. Then the second one we have seen the non-persistent, sorry, and the third one is the persistent, right? So here the station. So this is the A station and this is the B station and C station. So multiple access control protocol, whenever they access the link or the carrier, right? The very first one, whenever it senses the channel and if it is free here, right? At that time, station A will transmit its frame, right? Even though the station B is transmitting here, right? But station A cannot know whether B has transmitting or not. A will get to know only when the B station data reaches here, then only it will get to know. Otherwise, it cannot predict or it cannot be known. So that's the reason here there will be high probability of collision will be there, right? This is the one persistent uh, protocol and the other one is the non-persistent protocol. So here whenever it has the data and senses, if it is free, it will send. But in the here non-persistent, it will sense, stations will sense. If it is free, it will wait for certain time. Okay, random amount of time, it will wait. Then again it will sense. Again, if it is free, then it will transmit the frame, right? So compared to the one persistent, the non-persistent persistent collision is less. And the last one is the persistent, right? So here it will be, it takes the advantage of the both the technique, one persistent and non-persistent technique. It will wait for random amount time. Okay. And the second one, it will calculate the probability under which it can transmit the frame, right? So now we will see the carriers carrier sense multiple access with collision detection protocol, right? So in the earlier case, it is to just sense it, and if anything is there, and it is to, if anything, if any other stations have sent any data, then it has to, defer its transmission, right? But there is a high probability of having the collision there, right? And they those three techniques are the methods, they won't detect the any kind of collision. Even if collision happens, it will happen, right? So one technique they have developed for collision detection that we call the CSMA with CD, that is the carrier sense multiple access with collision detection. So when any station willing to transmit the data, the very first one, what it has to do is it has to sense the carrier, right? It has to very first one, it has to sense the carrier, right? And if it finds the carrier free, then only it can transmit its frame. Otherwise, if it is not free, it has to just defer its transmission because the other person or the other station is transmitting the frames. So that is the very first step in the CSMA CD. So the main question here it will come. So how to sense the carrier, right? So for that, each station can sense the carrier only at this point of contact with the carrier. So for example, you can see in this exam scenario. So this is the channel or the what you can say is the carrier, right? CARRE. So it's a carrier, and four stations are there. And this the circle, the black circle that indicates the point of contact of station A to the carrier. Right. Similarly, B, C, and D. Correct. So each and every station, whenever they have the frame, they very first one, what I said is they have to sense the carrier. So here it will sense the carrier. How to sense the carrier? That is a very important one, right? So we are human and we have the multiple sensors so that we can feel, something and we can say that so this is the particular fruit or this is the particular situation kind of thing. But in the network scenario, how to detect somebody is sending or not, right? Suppose this is a and this is a B, right? Suppose A sends the signal means it will be like this, correct? It will be like this, then it will be reaching here, correct? So in general scenario, whenever A wants to know, is there anything in the channel? So how to do that? That can be done using estimating the energy in the signal, energy in the channel, right? So E is the energy in the y-axis I have put and the time in the x-axis, right? Sorry. So whenever the frame is there, the energy level will be like this. Okay, so this what we call frame transmission. So I'll be writing in the short FT, frame transmission. Okay, and its energy level, for example, you can think of it's a X. Okay, and whenever there is no signals in the channel, then it will be zero only here. So it's a zero because here it's a zero, correct? And so this indicates that it's idle, correct? The channel is idle. Okay. So whenever there is a collision happens, right? So the energy of the signal will suddenly increases like this. So this indicates the collision has happened. This is the collision signal. Means here in this scenario, suppose this is the A is sending and similarly the B is sending like this, right? So in both, right, two signals are there. If you both multiply, it will be increasing. So the amplitude will be increased. Correct. So similarly, again you can draw. Suppose one more collision is there. Suppose again it's idle. Collision has happened. So you can keep it as idle. And whenever it wants to send again the frame, and it will send. And suppose if again the collision happens, it will be like this, right? And if it is normal transmission without any error, will be like this. This is a collision and this is the idle line, right? So this is how actually in real time we will are the computers, right, or your mobile phone or the network service providers will get to know whether the other person, other system, other devices are utilizing the channel or not, a carrier or not, right? In this case, you can consider suppose the D, okay, D has the frame, and A is also having the frame. Suppose consider, and whenever the D station did checks the carrier, right? Whenever it checks the carrier, so as there is no frame has not come, means signal has not reached any from any of the station. So this guy D thinks that, so there is no frame, so that's the reason it is sending its frame in terms of the signal. So it's like digital to analog conversion, right? And A also thinks that, so whenever it detects here, so again it feels that, so no one is using the carrier or the channel, right? So what it assumes, so it's a free, so I can use for transmitting, correct? Even the B, whenever it detects and this signal has not reached at this point, and this signal has not reached this point, so what it does, it feels that it thinks that, so the carrier or the channel, so nobody is using and it's a free, so I can use it, so it start utilizing like this, right? So as a result, at some point of time, right? So here or here, so there will be the collision, right? And this kind of a collision, I want to detect it, right? So how to detect? So that's a main challenging here, right? So the second step in the CSMA CD, very first one, we know very good understanding about the very first step, sensing the carrier, how to sense it, and how is the waveform for the collision or successful transmission or for the idle channel, right? See the detecting the collision in CSMA CD. So the main responsibility of the CSMA CD is transmitting the station to detect the collision, right? And for detecting the collision, so the CSMA CD implements the one very important condition called this one, the transmission delay, right? The transmitting delay should be greater than or equal to twice the propagation delay. Okay. So how is this? How to derive this condition, right? That's one of the main interesting aspect. So before that, we'll just understand what it is meaning, right? So transmission delay, we know the transmission delay, right? So that we call the TR, that the packet length or the frame length to the transmission rate of the link, that we call the transmission delay, right? And in the propagation delay, TP, so it depends upon the distance between the source and the destination. So that is the D and the transmitting rate, right? If the size of the packet is smaller, then collision detection would not be the possible, they are saying, right? So first we need to know what is the packet size, right? So what is the packet size? So under which the collision detection is easily, or under which the collision can be detected very easily. So just I'll show you one. Yeah, before showing this one, I'll derive this packet size of the packet is smaller. So how much smaller it should be? So I should get to know that. All right. So suppose you are consider in the worst case, so we will be having the different cases, right? Suppose that this is the station A and the station B, correct? And this is the station C and this is the station D, right? So consider the worst case. The A, detects the channel and it is free, then it presumes that nobody is utilizing. So at this point, right, it will start sending the frame to the destination D. So till here it's fine, right? So some point of time, even D wants to send, so it will send it, right? So here, correct? At this point of time, this is the collision. Because the signal which is sent by the station A has not reached at the time when the station D detected, right? So it's presumed that, so no one is using, that's the reason. So from here, the D signal is sending, and from the here, A signal will be sending, right? So this is the collision, and the collision detected, right? It will be sending like this. So till here, correct? And here, one important thing is the transmission station, right? So here, I'm having this is the one, the first transmission station, right? Transmission station, STA one, and this is the second transmission station two, right? So whenever it detects the collision, right? Whenever it detects the collision, these transmission stations will get the, signal, right? Even they will get the signal. So at that time, what this station do is they will send the jamming signal, okay, to all the stations. So some of them here also, some stations will be there, right? So they will be receiving this jamming signal, right? This is the jamming signal, right? And this jamming signal, which is maximum, uh, you know, uh, what you can say, the length of the data packet of the jamming is maximum 40 bytes. Okay, this is for the technical details, so we are not bothering about the how much it is, right? So in this scenario, you can easily see the transmission station A, it will be sending the data or the signal, and at this point, say for example, point P, right? There, the collision will be occurring. So as a result, the both the stations will be sending their jamming signal in order to defer the other stations to transmitting the data, right? If they start the transmitting the data, again the collision will happen. So they have to defer their transmission for some random amount of time. So that will be calculated, right? So here in these situations, so how much transmission time each station has to take, right? So what is the main motivation of explaining this diagram is to find the minimum frame size which is required to detect the collision in the channel, right? So here, from here to here going the frame, right? It takes the TP time, right? T propagation. T propagation will be taken, right? And if I say the frame, it has to reach to D, correct? And if I say again, successful transmission of a frame A, right? Means I need to consider the time taken from the A to D and again back from the D to A, right? So this is the total time taken for successfully sending the frame, right? So here I need the total propagation 2, right? So you can say this is for the data and this is, you can say, for the acknowledgement or for the jamming signal, okay, from here to here. And so this is the arrow I'm saying, this is for the TP, the first TP, and from here to here, the second TP. Either it's an acknowledgement or it's a jamming signal, right? Now I need to calculate the transmission time of a frame, right? This means the time taken for a frame to transmit it. So that is the TT, right? And this TT, successfully I need to transmit it. So this transmission time of a frame should be greater than or equal to this time. So it's a TP plus TP. So it's 2 times TP, correct? And we know the TT, right? It's a time required to transmit a frame successfully, correct? So it's a length of a frame to the transmission rate, and it's a greater than or equal to 2 times TP, right? So the length of the frame should be greater than or equal to 2 times T propagation into R, right? So this is the frame length. This is the minimum frame length or minimum frame size we need to use in order to detect the collision in the channel. Okay, fine. So now we'll understand the condition under which to detect the collision with the example. Whatever I have shown now, we'll see in a with a real-time example. Right? Consider at time 10 a.m. Right? The station A senses the carrier and it finds that the carrier or the channel is free. Okay, so the main aim is to station A wants to send the data to station D. So this is the aim of our example in this, right? And so for that it will sense it's channel is free or carrier is free. Then it starts sending its frame to the station D, right? And we have considered the propagation delay here from this point to this point. It's 1 hour, right? And suppose consider so at this time 10 hour 59 minutes 59 seconds when the packet is about to reach the station D, right? So at that time the D will be, when it will detect it, the signal has not reached here. Okay, at this time, then it will start sending the packet, right? So as a result, there will be collision going to occur at 11 a.m. Right? So at this time, this time, right? The D will senses and its channel is free. So that's the reason it will send. So as a result, the collision will be going to occur, right? So after collision occurs, right? After collision occurs, the collided signal starts traveling in the backward direction, right? It will be like this. It will be traveling. Okay. And for a station A, in order to detect this collided signal, right, it must be still transmitting some of the data, right? So the transmission delay of a station A must be greater than or equal to 1 hour plus 1 hour. So it should be more than or equal to 2 hours to detect the collision. And these conditions we have just now derived, right? This is the condition. TT is greater than or equal to 2 times TP, right? Or length of a frame should be greater than or equal to 2 times TP into transmitting rate of a link. So this is how we will be going to detect it with this is very important, with keeping the minimum frame size as this. So there are two cases are here. So in the case one, no collided signal comes back during the transmission. Means it's 100% successful. So no issue here. So no need to think of here. So it's a noise free or collision free. So no errors. It's 100% successful right away. In the second case, the collided signal will come back during the transmission, and that indicates the collision has occurred, right? And the data packet is not transmitted successfully. That means so we need to follow to the third step. So that is the releasing the jam signal. So whenever there is a collision occurs, at that time we need to means the transmission station need to transmit the jam signal, which I have shown in the previous figure, right? So as I mentioned earlier, this jam signal should be 48-bit long, right? And it is released by the transmitting station as soon as they detect a collision, right? The station A and the station B, right? And they are transmitting the, and they have detected somewhere here, suppose say, right? So what they do, they will be releasing or transmitting a jamming signal like this. And whoever will receive this jamming signal, so after receiving this, they will defer their transmissions immediately. Otherwise, they are going to encounter the collision, right? So now we will develop the uh, algorithm CSMA. CSMA. Right? So we have now got a little bit idea about the what is the carrier sensing multiple access protocols, right? And the carrier sensing multiple access with collision detection, correct? So now we will start developing the algorithm or the flow chart of this, right? So at the very first, we need to start the program, right? So that's the reason I am writing here. Then the second one, so earlier I have, whenever I was doing the algorithm development, so there I have mentioned that we need to first, initialize the of attempts the station is making, right? That is the transmission attempts. So at the first one, at the first time, it's the number of transmission is the 0. So we are initializing it to 0, right? Fine. And as we are using the carrier sensing multiple access protocols, so we need to apply any one of them, right? So we are having the very first one is the one persistent, right? And non-persistent. The final one is the p persistent methods, correct? So these are the three methods we need to apply. So the algorithm will be choosing depending upon the context any one of these algorithm, right? So I'll make a small good. So once the algorithm chooses any one of these methods, right? So after choosing this one, so what it has to do is it has to transmit, right? So the first one is need to check whether transmission is done or these conditions we need to check here. Okay, so this is the condition block where we will be checking the different conditions. And in our case, we are having the two different conditions. The very first one is the transmission. Is it transmission done or not? And if, and again, we are checking the whether it is detected the collision or not, right? And the output from here, we are having the two things. One is yes and another one is no, right? Suppose if it is a no, right, then it has to again retransmit it. It's a no, correct? And suppose it's a yes, right? So if it is a yes, yes, then it has to again check the collision detected or not, right? Because if it is yes means the transmission is done, right? Or you can say you can remove here the collision detected one. We will just say the transmission done. Again, I'm checking the collision is detected or not, right? So now the transmission is done, then I will be detecting the collision, right? So I'll be using the those methods, right? And I'll be detecting the collision. And if there is no collision, correct? So if it's no, the collision is not detected, correct? So that means the successful. The frame which we have sent, it is successfully reached or successfully transmitted to the destination. Fine. Now, suppose it is no, suppose it is collision is detected. Yes, collision has been detected. So what we need to do, right? So in the earlier, uh, you know, image, I have said that whenever it detects a collision, the transmitted stations will send the jamming signal. Correct? So here, send a jamming signal. Correct? Fine. Okay. After detecting the collision, the stations will send the jamming signal. Correct? Fine. So after sending the jamming signal, we need to again see whether we need to go for the retransmission, correct? So for that retransmission, I should be or I should increment the number of attempts, correct? So for that reason, I'm incrementing the number of attempts the transmitter is having. So earlier it was 0. Now here it will be the k equal to k plus 1, right? So once I increment this, correct? So I need to check whether that limit has crossed it or not. Correct. So the maximum limit, whatever we have given to the stations, whether it has crossed it or not. So that was the Kmax, right? So this condition it will be checking after incrementing the number of transmission. Correct. And if it has, crossed this limit, sorry, suppose if it has crossed this limitation, right, then what the station has to do is it has to either drop the packet or abort the process. So whatever the frame or the packet is there, either it has to drop or about the complete process involved in it, right? Suppose it has not reached, right? So here I will write yes, and here I will write no. So it has not crossed the its maximum limit. So the same thing which we have, done it in for the earlier algorithm development, right? So what we have to do, we have to choose the random number, the random, right? We need to choose a random number r, and this random number r, which is ranges from 0 to 2 raised to k minus 1, correct? So after choosing a random number r, correct, it has to again wait for certain random amount of time. Right? Random amount of time. So that what we called in the last class was the back of time. B, back of time. So it has to wait for this amount of time. So once it is waited this amount of time, so what it has to do is again it has to sense the channel, right? And if it is free, right, again it has to transmit it, correct? So for that, what we have to do, we have to connect here, right? After sensing the channel free, it has to choose any one of the method, then transmission need to be done. So this is the complete algorithm for the CSMC. So any doubts so far, students?
No, sir.
No. Okay, thank you. Fine. So that's what I wanted to discuss today. And CSMA CA, I'll be discussing in the next class. And regarding the question paper, right? So many of the students have not attended the. Wait, I'll just stop this recording.